How's it going, guys? And in this video we are going to be talking about linked lists in Python. We're going to be introducing the subject as well as working through a demo to hit home the core points. And so the main thing to ask yourself is, why do we even care about linked lists in the first place? And so when you're learning about data structures and how are computers remembering stuff, how are they persisting things, linked lists are an alternate way of saving a collection of data to arrays. And so with arrays, when we define an array, we have to say that this array will be this many spots in memory. So if I declared an array of size 10 integers, that means that the operating system is going to have to go find 10 integer-sized memory blocks consecutively in memory and save them for my array. And when it does this, if I decided that I want to add on a 10th or a 19th, like an 11th element onto my array, or I want to remove the 10th element and I only have like a 9-element array, the computer can't really do this unless it creates an entirely new section of memory blocks that are consecutive right next to each other, and it copies all this data over. And so because of that, these arrays are not really dynamic in size, and they just take a really long time for us to change the size of them. So it can slow down a lot of our computations. And so what linked lists give us is an ability to very readily change the size of our linked lists by pushing and popping off nodes on our linked lists. And so with these linked lists, they're made up these fundamental building blocks of nodes, and these nodes are composed of a data component as well as a memory location component, or a pointer. And so in a example linked list, like what I have here, is if we had a linked list and we want to save, let's call it a collection of characters. I should make the font size probably smaller here. But if I had a collection of characters, like if I wanted to save the character A, I should probably make this bigger, sorry. Do size 20. So if I wanted to save the character A in one node, I'm going to save it there. I want to save another character B, and I want to save a final character C in this node on the far end. What's going to happen in memory is that we've got basically 3 separate places in memory where we can save this thing, basically decentralized almost. And then with our program, what we're going to do is we're going to tell it the location of the next node. So the next memory location of your first node will point to your second node, and then the next memory location of your second node will point to your third node here. And then finally, what's going to happen for your final node, or the node that's on the tail, is going to be pointing to none in Python, or null, but in Python it's referred to as none. And so the other thing to make note of here is that your first node of your list is commonly called your head node, and then sometimes you're going to call your last node the tail. So that's the kind of structure that these nodes are going to take on. So we're now able to save a collection of data, so A, B, and C characters, and connect them together in such a way that if I wanted to add on, let's say, another node, so if I had another character here, and I'll make this blue just so it looks prettier, we can do that fairly readily, because we would just go in here, and then we would say that this final node will have a data of D, and then I'm going to make it point to none for its memory location. And then we would just write an algorithm to say for the third node, or the node containing the data C, is that it will now point to this new node here. And so that is how an algorithm is going to dynamically change the size of our linked list without having to completely delete everything and then create a new set of data points. And so this makes it much faster. If you're doing a lot of appending or pushing off of data in your data structure, linked lists are a very attractive option. And so this is the theory behind it. There are the key disadvantages here, is that if we wanted to find a node, it requires us iterating through our entire linked lists, potentially in our worst case scenario. And so these retrieval operations can get very long because of this. So if in our worst case scenario, I wanted to find which node had the character D in it for its data, I would have to go to node A. Would I see if A is equal to D? No. Go to node B. Is B equal to D? No. Go to node C. Is C equal to D? No. And then go to node D. Is D equal to D? Yes. So it would have taken me many operations, 4 operations, to have found node D, and that's what makes it a problem for some of us. And so retrieving data is not the strong suit of these linked lists. However, the ability with which we're able to change the size is. So now what I'm going to do is open up a Python terminal here. And basically the goal of this exercise is going to be to define classes in Python to show a linked list and to count the number of nodes inside of our linked list. Okay, and so the very first thing we're going to do is define a class to be our node, and so that we can instantiate objects or nodes from this node class, this blueprint that we're defining in Python. So the first thing I'm going to do here is just say class node, and I'm going to define the constructor as follows: def underscore init underscore, and then so each node, as we've already said, is going to contain data. So self.data, and this is going to be a required property to be specified when you are defining this. So if I'm supplying data, which is required, that will be the data property of this node object that I'm creating. And then in addition to that, I'm going to have this self next, and this is going to get next. And so the other thing I'm going to do here is in Python make use of the optional class property and within the constructor. So what I can say is if I say next gets none, what that means is that if I don't specify the actual next property when I define this object, then it will assume that it's none. Okay, and so this is what our node class looks like. And then what we're going to do here is define our linked list class. And so within our linked list class, I'm going to make this pretty basic. It's not going to require any properties when you're creating it, but we are going to be creating exactly what we had on our previous page, where we had node 1 with the data of A, and then node 2 with the data of B, and node 3 with the data of C. So the very first thing you're going to do is to basically declare and define the data of the nodes. So I will say, I'm going to declare the first object, the first node object, to be head, and head will be built off the node class that we just defined. And then the data of this is going to be A. And as much as I would like to here define what the next node is, I can't do that because we haven't even defined it. So we have to basically literally just declare and define the nodes. So head will be the first node, and then we're going to have something I'll call N2. This will also be an object of the node class, and this thing will have data of the character B. And you can use any data type as well. So it's another strong suit of this thing, is that you can throw in different data types into your linked list. It doesn't just have to be a character. It could be an int or a float or whatever you'd like, but I'm just going to stick to characters right now to keep it simple. And then finally, I'm going to have a third node, which is this, and this is going to have data of the little character C. And so now that I've defined all of these nodes, the next thing I'm going to be doing here is actually linking or link together the nodes. And so the way we're going to do that is as follows. So we're going to say that for our head node, and I will make these objects of this class, or properties of this class, sorry, so we can actually reference them in this example. So basically, as soon as we declare or create a linked list object, it will be creating these three nodes every time we do that. So now we're going to be linking together the nodes. And so when we do this, what I want to do is I want to say that for self.head, so for the head node of the linked list object that I created, I'm going to say that the next node will be node 2, self.n2. So it's the actual object's location in memory that we are now referencing. And I'll do the same thing here. So I'll say self.n2.next. We'll get self.n3. And so what's happening in lines 18 and 19 here is that I'm saying that the next property of the head node and node 2 will now have a value that is not none, because I want to be telling them that they are now pointing to the next node in that linked list. So I'm defining that right here. And now what we're going to do is the following. We can just run this code to see if it actually executes correctly. So I'm just going to create an instance of the linked list class as follows, and I have a break statement right here so we can look at what happens. So control shift F9 in PyCharm to do this. And so what we see here is that in the self object, so in the linked list object that we just created, we now have, a head node object, an N2 object, and an N3 node object. And if you look at each of these nodes and expand this, you can see that the head node has that data A, and then the next property of this head node is this memory location, the 32F0, and that's pointing to node 2. And node 2 has this memory location as well as data, and that is pointing to 3DD0. 3DD0 is the node 3 object, and then finally node 3, because we're not linking it to any other nodes, is going to have its next property be none or null. And so this is our successfully defined linked list object now. And so what we want to do is create a way to determine the number of nodes in the linked list. So I'm going to define a method within our linked list class, and the way I will do this is as follows. So just tab that out, def count nodes. And so what's going to go into this class, or this method, sorry, will be the head node. So I'm going to assume that this is the head node. So assume the head node is provided, and return the number of nodes until tail. And so what we're going to do here is the following. So the first thing we're going to do is instantiate a counter. So I'm going to say count, let's do node count gets 1 to assume that we already have our head node, which is the reason why we got here in the first place. And so the next thing we're going to be doing is saying that I'm going to say current node gets, and we're going to say head node. So we're just going to say, let's assume that. And then we're going to enter a while loop. And so while current node dot next, which is that property of our nodes, does not equal none, I'm going to then assume that we have another node in our linked list. So I'm going to increment node count. So node count plus equals 1. And then next, what I'm going to be doing here is now reference the next node by updating the current node object. And so the way we're going to do this is we're going to say that current node gets current node dot next. And so this is something that gets a little bit tricky, but you have to think about it for a second. So basically, if we were on our head node right now, head node will be current node. I will increment the count, and now I want the current node to be the next node of this node that I'm working with here. So current node, so for the head node dot next, this will be node 2. And then when node 2 becomes this, we will again see that node 2 doesn't have null as its next property. So we're going to increment the count again. And then finally, what's going to happen here is we're going to be at our third node, and that node will not have a next property. So we're going to walk through this in the debug mode to see it play out in real time. And so I will put a print statement here as well as a breakpoint. And now what we're going to be doing is the following. The other thing I should do is return the node count after we are done iterating through our while loop. And so what I will say is we're going to print self.count nodes. And the other thing I'm going to throw in here is our self.head node. And we're going to uncheck that breakpoint. And we will run this code as follows. So stop, and then start a debug session, and we'll talk through what's happening here. So we've instantiated our linked list of head, n2, n3, and now what we're doing is we're iterating through this list. And what happened here is our current node was the head node. The head node, when in here, it did not have none as its next property, so we increment the count, and then we reference the next node. So if I look at all of the nodes here, we can see these memory addresses. So head node was FCB0, and we can see that right there. And then current node is this F210. So F210 is node 2, so successfully just changed us to node 2. And I'm going to do another line by line here. So does node 2, so current node, does this have a next property of null? No, it does not. It's pointing to node 3. So we're going to enter into our while loop again, and we're going to increment node count. Now we're at 3. And now what we're going to see is that our current node will be pointing to node 3. And so we're going to update current node. And we're going to go up to here, and now we can see that for node 3, the one with the data C, has a next property of none, and because of that, we're now going to exit our while loop. And finally, what we're going to do is return the actual node count here. And so if I do one more, we're going to see that we're getting 3 out of this list. And so that is going to wrap things up for this introduction to nodes, linked lists, as well as how we can iterate through these linked lists. I hope this is helpful. Thank you all for watching. Let me know if you have any questions, and take care.